Good morning, Tanvir sir.
Good morning, madam. How are
Good.
you?
I'm doing good, sir. How are you doing? Thank
Yeah,
you.
yeah, I'm doing good.
We have 5 more minutes. Yeah.
Yeah, 5 more minutes. Let everyone joins. If it is
Yes.
5 minutes delay, doesn't matter, but everyone should supposed to be joined.
Yes, yes, sir. Yes, sir. Sure. Yeah.
Is my screen visible? Can you see my PPT here?
Yes, sir.
Soumya madam. Hello, Soumya madam. Soumya madam, can you hear me? The number of participants are very less. Like, is it the normal strength? Should I supposed to start, Soumya madam? Arati, how many were there? Arati?
Sir, around 30 to 40.
30 to 40 is the normal strength. So we expect that after some time they will join.
Yes, sir.
Okay.
ಮ್ಯಾಮ್ ಪಕ್ಕದ ಕ್ಯಾಬಿನಲ್ಲಿ ಏನಿಲ್ಲ ಆ ಕಡೆಗೆ ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಡಿಸ್ಟೆನ್ಸ್ ದೂರ ಇದೆ
Tanvir sir, you can make me co-host. I can.
ಬಸ್
mute
ಮೇಕ್ಸ್
everyone.
ಮಾತ್ರ ಕೊಡ್ತಾರೆ ಮ್ಯಾಮ್ ಅವರು
Tanvir sir. Yeah, thank you.
Soumya madam, let me start.
Sure, sir. I'm also messaging in the group. You can, sir.
Because machine learning now started in the last class. Also, few slides I had gone through, and then I had to stop due to time. So
Sure,
I'll
sir,
start.
sure,
I'll
sir.
start from those parts also. So those who are joining now, so they can go through with that, and those
Yes,
will come
sir.
back later. Okay, I hope that they will be going through already.
Yes, sir.
Yes, sir.
Please,
Yes, sir. Gentle reminder, sir. Gentle reminder. Supervisor, unsupervised. You said that you will cover this time.
Yeah. So actually, guys, my key motto of this particular session is that to make you clearly understand about the machine learning, the different types of the machine learning, the process of machine learning, what are the types of the machine learning, and why do you use different types of machine learning for which particular circumstances, for which particular situations we pick which kind of machine learning, how the different kind of machine learning works, and how it can be used for deep learning. That will be my prime motto of this delivery of this session, because already you have learned about the neural network a bit from the different from Dr. Tamin Sarmi madam has taught you, taken the session on that. Sunanda ma'am has taken session on that. Then Shaila ma'am has also taken the session on neural network. So even my portion also covers neural network, but I'll focus on machine learning mainly. Is it okay? Yeah, because machine learning no one has yet covered, I think. Has any other session has covered machine learning or any part of it? Hello, sir.
No.
Okay. Fine. I'll focus mainly on machine learning. So guys, as I've started in the last class, these slides are covered in the last class. So what do you mean by machine learning? There are many definitions of machine learning. Three of the, the most widely and most simple definitions I'll provide over here. So I'll start with the simpler till the most formal one. This is the most simplest definition is that machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and particular algorithms which are particular to machine learning to imitate the way the human learns. So the way you learn from a particular situation, the same way the machine can learn, and also the learning can be optimized and enhanced the quality of learning through different environmental learning. I mean, whenever the time will go through, it will automatically improve this learning by experiences. So that's what the machine learning is. It's one of the most important aspect of artificial intelligence. There will be no single artificial intelligence related talk. There will be no single artificial intelligence related, discussion or workshops or applications where you'll not learn about the machine learning. It's so important. It's so much important. It's such an important part of artificial intelligence. But both are not same. You should not supposed to make that artificial intelligence and AI and ML are both same. No, they are having the difference. AI is a larger field, and ML, the machine learning, is a subset of it. Like the deep learning is a subset of it. Now, from the deep learning, neural networks is a subset of deep learning, but it covers the most important aspect of deep learning, as you have seen in some other sessions. The underlying concept of deep learning is neural network, correct? Yes. So we'll be learning about the machine learning. So before that, we'll go through the next and most formal definition of machine learning. That is, as you know, that the artificial intelligence, the term has been coined in 1956, and in 1959, the term machine learning was coined first. So the most formal definition is what we have found over here in the bottom. It is there. A computer program is said to learn from experience E with respect to some class of task T and performance measure P. If the performance at task in T as measured by P improves with experience E. So basically it's telling that there are n number of tasks T. Okay. The task may be anything which the machine can learn. So that task T, the set of tasks or a single task T, should supposed to be measured by a particular performance measure P. There are different performance measures to measure the performance of outcome of a machine learning job. So now this performance of the task T or the set of task T is measured by the performance matrix P. Yes, and if it improves over the time based on the experience E, then it is a proper and a very optimized solution of a machine learning problem. Is it clear to you? So not only the problem will be there, the problem should be solved, measured, and should enhance for a particular environment with a particular experience. The experience are generally obtained from the environment. When I'll go through with the process and the reinforcement learning, especially as a type of the machine learning, I'll be explaining it in a bit more detail. So the machine learning, is go through with these 4 levels. Yes, because it has the ability to learn automatically and improve from the experience, right? Without much, what to say? Without much, input from the programmer. So that's what the machine learning is. So we have first the data. As you can see, look at my cursor. We have first data. The data is raw. The data cannot be used directly for the machine learning. So you go through with the training the machine. So we train the data also. It's known as the pre-processing of the data. So in pre-processing, we clean the data, we transform the data, we remove noise from the data, and we do the collection of data. We accumulate the data from different sources. Then we sometimes reduce the dimensionality. There will be multiple dimensions in the data. Suppose thousands of dimensions are there, but in our particular machine learning job, we just require 80 dimensions. Yes, so that will be known as the training the machine, the training the data. Yes, then we'll build a machine learning model. The soul of the machine learning model is a machine learning algorithm. But the algorithm is not only sufficient for a model. We'll train the model, we'll build the model based on the training first. We'll provide a certain and higher percentage of the input data to that particular algorithm and see that how it is working on that particular data. Then based on the result, we'll see the performance of the result by a different metrics, different measures. And then based on the measures performance, if you see that the performance is suppose 90%, we're expecting 95%. So we optimize the model. We'll optimize the algorithm. So building a model is actually optimization and making the tuning of the model, tuning of the algorithm correctly. And after that, we'll go through with the prediction. If the model is properly designed, if it is working properly, the algorithm, then it will predict the proper thing. The measures will be higher. How can I understand the predictions are good or not? By using different measures, we can see that how the training is going on properly or not. It should supposed to increase. So last time the prediction was 90% correct. Next time, if it is properly optimized, the prediction will be 95% correct, 93% correct, or 100% correct. There are little chance that 100% correct, because in complex real world job, nothing is 100%. It's very difficult to have 100% correct result, but we can go near perfect results. That's what the basic model of the machine learning. Now, the thing is that why the machine learning is coming so quickly and so widely in the field, and why you are so much eager to learn machine learning in artificial intelligence. Yeah, the reasons are three mainly. Actually, the main reason is data. We have a higher processing capacity, you have good algorithms, those are there. But the main reason is the data. Now, cloud data is, you have a separate technology, right? Cloud technology. Now we have a separate domain in IT industry that known as the cloud technology. So basically what happens, the data is generated and it is being stored into the cloud of systems. Yes, like we have the G Drive, Google Drive, and many other cloud services, Amazon EC we have. Then we have lots of actually which provides the data through the cloud. So those cloud data can be analyzed and get useful insights. Similarly, the data is generated by Internet of Things. Internet of Things driving the Industrial Revolution 4. So Industrial Revolution 1 were there some 200 years or 300 years ago, then Industrial Revolution 2 were there, then Industrial Revolution 3 were there, and there is a Industrial Revolution 4 which we are living now, which is driven by automation. That is it is expected that a big factory will be having just 10 to 15 employees, and the entire factory will be run through the smart robots, which will communicate among themselves using the sensor networks and different communication channels. The production line will be totally automated. Yeah, that is the Internet of Things results which we can expect from the Internet of Things, and that generating lots of data. So those data also need to be analyzed. Yes, that the robots are generating the data, the robots are performing some job. If the robot is failing, why it is failing, when the robot can perform better, when the more perfect things can be happening. So all these things can be analyzed through the data. Now another reason is the social media. So before 10 to 15 years, there was just a single social media. We used to know about the Orkut. 15 years back, I think Orkut were only there into the market. Then we have Facebook, and now it's like all of the social media users are available here. And India is one of the highest number of social media users, country with. So we have lots of the social media data. We should supposed to go through with the social media data. Also, we should supposed to know people's emotion on that, how people are thinking. So the political entities can use the social media data for their election purpose. The government can use the social media purpose for governing, and the industry can use the social media data for their better prediction of a particular market. Yes. So over 2.5 quintillion bytes of data are created every single day. And it's not only growing to grow from there by 2020, it's estimated that 1.7 MB of data will be created every second for every person on Earth. So this is a good quote from a particular research paper. So it is definitely true here in 2022. So definitely 1.7 more than that amount of data is being generated by each person on Earth. So if you have 800 crore people, so that amount of data is being generated, and that has a significance in that. We can mine the data, we can get the knowledge from the data, you can get prediction from the data, and you can get different advantages in business, in governance, and industry, and business, and in many other sectors from the particular data. So to analyze the data, we need machine learning algorithms actually. So that's how the machine learning is coming to the picture. So that's the first reason. The increase in data generation is the first reason why you need the machine learning kind of things. The increase of the data is the first reason. Yes, big data is produced now. The big data which having the unique capacity of and the features in the data, like we have a large volume, very quickly generating in a large velocity and fast it is generating, and it's in the veracity, there's a noise in data is too much. So all these things are there. So to develop competent task solution on big data is a big issue actually. So that's why we use big data, machine learning to analyze the big data. Next thing is that you can see that here you can see in the bottom that improving the decision making. So that's a very widely used reason for machine learning. I mean, very important reason for using the machine learning. like to predict the sales. So Flipkart wants to predict the sales, which items will be sold properly and more. How can you understand? By machine learning algorithm, it will execute on its server's data. Yes. To predict the downfall of a particular stock. Okay, we can use the machine learning for that. Yes, to identify that what are the vulnerabilities a particular network has. So it can see that the network traffics, and you can see that what are the network traffics is having abnormalities in behavior, changing IP address, changing username, and all these things. So we can understand that the hacking attack can happen from those particular network, block them. Yes, so we can have the predictions. We can have a good decision making, means we can save our networks also. Next thing is that to uncover the pattern and trend in data. So it's a very important thing is that sometimes the business needs to uncover the pattern and trends in particular data. Suppose, for example, we just want to see that what are the patterns a particular person is purchasing items. So you are going to, in a computer shop, you are making, you're checking that when a particular person is purchasing a HP mouse, then he is also going for a particular mouse pad. Yes, which have good quality. So you are seeing that what kind of item should be prescribed for a particular user. So who is purchasing a sasta, the cheap mouse of suppose 250 rupees, he's not going to purchase a costly mouse pad for that, or a keypad for that, or something else like that. So you can see that patterns of users behavior, the trends, how the people are reacting in a different way. So based on that also you can understand many things. You can predict many things, and that can have the advantages in business and governance and all other things. Like the trends you can see in the voters perspective, you can see that how people are reacting for political issues in Facebook or in Twitter or in any other social media websites. Okay, and based on that you can have essence. You can have the predictions that this party may come to the power if they do these things, or if they don't do these things, then their party may be having a better chance to come up, or they can stop their downfalls. So you have to see the trends of the people's behavior. So that's one of the main reason why you go through with the machine learning. And the next thing is that to solve complex problems. So what do you mean by solving the complex problem? There are certain problems which cannot be easily solved. Yes, like reading the genome sequences to know that the future diseases like cancer and all. It's a complex problem. To recognize the image is very difficult actually. Suppose a car is going through with 80 km/h speed, but the speed range limit was 60 km/h. So the CCTV camera should supposed to have the capacity that it should supposed to know the number, the code. What's the name actually? The bike, each bike has a code, right? Number plate, yeah. So it should supposed to automatically read the number plate, and the thing should go to the police station, and it should supposed to give a notice to the particular user that this thing has happened. Are you clear? So solving the complex problems, that can also be done by using machine learning. How we'll go through later. Okay, just I'm teaching you the basic things about what we can do and what the need of the machine learning now. Now we are coming slowly into the machine learning. Basically, we are coming to the machine learning now. So what is the machine learning? The terms we should supposed to know first. These terms will be keep on repeating. Okay, so please be a bit focused on these terms. That these terms will go through later. Okay, repeatedly we'll be using these terms. So that time it's not feasible that each time you explain the things. So the first thing is that algorithm. So what do you mean by algorithm? Algorithm, as you know that each and every computer science student knows it, and those are not from computer science, they should supposed to know also, that is a set of rules. Yes, to learn pattern from the data in machine learning. When you use the algorithm, we use that not just a set of rules, it's a set of rules and some statistical techniques, some mathematical model also used in algorithm. So those mathematical models, that particular way will be implemented so that it can fetch some pattern from the raw data. The data was of no use, but algorithm will make it a useful, an useful entity, so that we can get the important feature from the data. So that's an algorithm. What is a model? The soul of the model is an algorithm, but the algorithm is optimized by training using the data. Are you clear, right? So you have an algorithm, machine learning algorithm, but machine learning algorithm cannot be told as a machine learning model. Yeah, the model will be run by the algorithm, but the algorithm has to be trained. Means you have to see that how the algorithm works on a particular scenario and how much performance it generates. Then only we can tell that that particular algorithm has been trained for this particular model. Suppose a machine learning algorithm is there, k-means. I'll explain this algorithm later. Today afternoon I have a session, I think, on MATLAB. So I'll go through with the k-means algorithm only. I'll make PPT for that. So it's a very popular algorithm and very simple algorithm also. So it's best to start with k-means. So suppose I'm using an algorithm, k-means algorithm. It's a machine learning algorithm, unsupervised machine learning algorithm. So when you are using k-means unsupervised machine learning algorithm, we can't just use k-means for each and every machine learning model. Yes, we can use k-means algorithm, but the algorithm has to be, trained by different number of clusters. So you have to see that which particular number of clusters are good for this particular application. So you have to determine the perfect number of clusters which will be used for that machine learning algorithm. So that deriving the number of cluster will be part of the training. Yes, you cannot give very random values. You should supposed to have, okay, another thing is that to model a particular machine learning algorithms, you should supposed to have the domain knowledge. The more experienced you are, the better you will model actually. And it comes over the experience. You cannot come to the first day and make a perfect model. Yeah. You can implement a perfect algorithm. You know the machine learning algorithms, you know the code, you know Python or Java or MATLAB and all. So you can model that. You can implement the algorithm. The perfect model require an experience. So that's what the machine learning algorithm is. Next thing is that the predictor variable. What is the predictor variable? All variables are a part of the data set. Yes, these variables are the features, or you can say it's a dimension. These are the built-in block based on where we can get the information, based on what we predict the outcome. The ultimate motto is to predict the outcome in machine learning model. So these variables are the ground, it's like a pillars. Based on these pillars only, you can go till the level of the predictions. So predictor variables are features of the data that can be used to predict the output. Are you clear? Yes. Now we have the response variable. Response variable are the output itself. I mean, the response variables are the predicted outcome, which are predicted based on the predictor variables. So response variables are the outcome, yes, which is derived from the predictor variables. So let me give a very simple example so that you can understand it with real world examples, Okay. So suppose you are going through with big basket. Oh no. Okay. So big bazaar. You are doing machine learning for big bazaar. Yes. So you are a machine learning professional. You are working as an AI associates. Yes. So they have been told you that you find out that what are the items will be sold together, so that we can prescribe our users to purchase those things, and our selling will be increased. For example, for that particular reason, while sitting at Big Bazaar as an associates for the machine learning, what will do? You'll see that what are the items are sold all together. So you think that those who are purchasing bread and eggs, they're also purchasing milk, because they purchase this thing for breakfast. So the bread and egg and milk and jam. So you're seeing that there is a trend in the data. Are you clear? Yes. Are you clear? Yes or no? Guys, you can interact with me in case if you have any doubt. Okay. You feel free to interact with me. So these are the predictor variable. What are the predictor variables? Bread, jam, egg, and milk. So if these 4 items are there, you are predicting that the user is going to purchase items for breakfast. Now you can propose him some other breakfast items so that your sales can be increased. So you're learning, your machine is learning automatically that, okay, when a person is purchasing bread, jam, egg, and milk, he is purchasing for breakfast in our shop. So you can, next day when he comes automatically, or when he goes home, you can automatically send a message or email to his registered mobile number with Big Bazaar that we have cornflakes and we are giving it in 20% discount. So cornflakes is a widely consumed breakfast item, correct? Yes. Or you can also give similar items to up down the sale, like they are purchasing normal bread. Next time you are going to give that, we are going to sell brown breads, which are more healthier and it's far better, and it's prescribed by doctors, and all these things you can advertise. So what is the predictor variables here? The predictor variables are bread, jam, milk, and egg. And what is the response variable? Is it breakfast items is purchasing or any other items is purchasing? So it's a breakfast. So breakfast items, to determine breakfast items, you are using these base variables, correct? So predictor variables are this bread, jam, egg, and milk. And the response variable is either is the breakfast or lunch or cricket items or dresses, and all these things are the response variable. So here the response variable is what? Breakfast items. Is it clear, guys? Have I make it clear? Predictor variables and response variable. Any doubt, anyone?
No, sir.
Okay. Okay, so this is about the predictor variables and response variables. Will be keep on these items, these terms now will be in your lifetime. If you're into AI department, or if you're into machine learning, if you're into DS department, then machine learning is also there. It's common in DS also. And if you're interested in computer science, anyhow, this is a emerging fields, and these terms will be keep on coming to you always. So better to learn it very clearly. Okay. Next is the training data. So what do you mean by training data? See, the training data is used for training the model. The training data is used for what? To training the model, to make the algorithm works properly for a particular machine learning model. So training data is collected and it is used for testing the efficiency of the algorithm. If the algorithm is, having a performance up to a certain level of threshold, then the model is perfect. Suppose you want 80% accuracy. So you are giving the training data. You are seeing that the 80% accuracy is being generated by the particular machine learning algorithm or not. If yes, then it's a model is created. So it's a training data which you are facing. So the question is, where from you get the training data? Yeah, training data is nothing but it comes from the input data only. Some certain percentage of the input data is used for training data. It's mostly more than the test data. It's like sometimes 60 to 80% of the input data is used as a training data. What is the testing data? Testing data is after training the data, the remaining amount of data you fed over there to test that now it's working, with the same capacity as is to work in the training data or not. Because you can't rely, because sometimes in some data, with some amount of data, your machine learning model will be very correct. And for the remaining amount of data, it might not be that much efficient. It happens. So you also test the data by using the testing data. So these 6 are the widely used terms associated with the machine learning. So if you have any doubt on that, you can ask. Okay, so we'll go through the process of machine learning. So how machine learning actually goes through, we'll learn that. Yes. So the machine learning process involves building a predictive model. Predictive models means you want to predict something, like the last example I show you, right? What you are predicting that the person is coming over here for purchasing breakfast item or food items, or sorry, dress items or sport items, or what, for Big Bazaar. Why is visiting Big Bazaar? For what purpose? So you want to see that the predictive model over there, based on his pattern of purchase, you want to just predict his behavior. Correct. So that's what the motto. The machine learning process involves building a predictive model that can be used to find a solution for a problem statement. Yes, the problem statement and solution. Solution is provided by the algorithm, and a problem statement will be the objective of the particular machine learning. So that's what the model is. So as you can see over here, my mouse is working. Okay. So as you can see over here, this is the defined objective. So first you are defining the objective. So this is the problem statement. What do you want to do by using this? What do you want to predict by using this machine learning algorithm, machine learning model? That is the first thing. Define the objective. Next thing is the data gathering. You'll gather the data for that. Next, then you'll prepare the data, means pre-processing the data. You need to pre-process the data now. You have to go through with the data so that the data becomes in a certain stage so that the machine learning algorithms can perform properly. Otherwise, each and every raw data cannot be processed. The algorithms cannot process the raw data. Keep this thing in mind. Suppose you're using K-means algorithm, because I gave an example of K-means algorithm before, right? So if you're using K-means algorithm, you cannot use it for categorical data. You cannot use for the document data because it's text data. It can only work with the numerical data, K-means algorithm. So if you want to cluster documents, if you want to group documents, then you have to transform the documents to a numeric value. Each and every words, each and every unique terms, unique words should be converted to its respective value or numerical values. That has to be done. Otherwise, k-means cannot be worked. So that data has to be prepared. Now we have the data exploration. What is the data exploration? It is known as the what you can say, exploratory data analysis. It can be also said as the exploratory data analysis. It means that you should supposed to now know the data, the data really you have to understand that what is the interconnection between the data. What are the interconnection between the different variables or different features, different dimensions, how the data are interrelated among themselves. You should supposed to know. Yes, you should supposed to know data well, then only you can go through with the building the model. So based after knowing your data well by data exploration, you should supposed to go through with building a model. So when you're building a model, you're using algorithm, machine learning algorithm. Yes, after that, you are going through with the model evaluation. Now, is the model is properly done or not? You'll be using testing data for that. After testing the data, if you see that the performance is coming, the performance P, as you have given the formal definition, is up to a certain level and you're satisfied with that, you can go for the predictions. And the predictions are generally, it is a continuous variables or it's a discrete variables. I'll go through with all these things one by one. So up to this is clear to you guys? Yes, this design is clear that you are starting from the defined objectives to the predictions step by step.
Yes, sir.
Okay. If you have any doubt, you can stop me and ask me here. Well, I think you can ask me doubts also. If you feel shy right now to ask and all, you can write down in a paper. Okay, and you can ask me at the end of the session. Now the next question is that the process of machine learning. The first step by step. I'll just explain in detail more. The first step is that define the objective of the problem. Yes. So here I'm giving an example. You can look at my mouse. This is the problem here. Weather forecasting using machine learning. So you want to forecast the weather condition. Yes, of a particular region. Suppose in Bangalore, you just want to forecast the weather for Bangalore, for nearby Jain University, or in this particular longitude and latitude. So what is the predictability of the weather? Tomorrow it will rain, or it will be cloudy, or it will be shiny, whatever it is. You just want to predict that. So what's the first step? Define the objective of your problem. So what's the objective of your problem? The objective is to predict the possibility of rain by studying the weather conditions. Yes, the input also clear to you that you have to study the weather conditions. Now you have to ask certain questions to set the objective. Now, these are the questions we have. If you ask these questions, then only you can be settled with the objective. What are the questions? The first question, what are we trying to predict? So definitely this will be either a continuous variable or a discrete variable. Either it's a continuous variable or a discrete. There are two kinds of variables. Variables can be defined and categorized into different levels. If you want to go through for the data mining, that's a different subject for that. And it's a different chapter for that. We'll go through with that discussion. It's not a time to explain all these things in detail. We have a certain limited time, and time framework. So what you're going to try to predict, either it's a continuous or discrete variable. I'll just give an example of a continuous variable. Your height might be a continuous variable. Your height. So if I ask what's your height, you tell it's a 5 feet 3 inch. Okay, and I'll ask another one, what's your height? It's a 5 feet 2 inch. Or if I ask another one, how much your height? Is it 5 feet 7 inch? If I ask another, what's your height? So all the heights will be in a certain range, right? It will come inside a particular range. It's continuous value, correct? It's continuous. There is no separation between that. It might be 5.1, 5.11, 5.15, 5.17, 5.19, 5.2, 5.21, 5.25, like that. It's a continuous value. So that can be also, we can predict sometimes, that kind of thing also. Or it's a discrete variable. Discrete variable means there is no interconnectivity between them. It's like all are discrete or all are separate. For example, if you want to determine the color, then all colors are different. It's red, green, blue, and all other. Okay, so you're going to red. Okay, red is separate. There is a difference between, there is a continuity between red and green. No. From green to blue. No. From blue to white. No. From white to black. No. From black to yellow. No. That is all are discrete. These are the discrete variables. So here in this particular example, can anyone tell, is it continuous variable you are going to predict or discrete variable you are going to predict? Anyone, please? Let we have an interaction. In this particular example, what you are going to predict weather forecasting, right? Using machine learning. So is it a, what kind of it is actually? Is it, we are going to predict a continuous variable or discrete variable?
Discrete, sir.
Yes, sir. Hello.
Discrete.
Yeah, it's a discrete. We are going to predict. Why it is discrete? Because we are either going to
It's
predict
not
yes.
stable.
No, we are going to just go through with yes or no, right?
Yes, yes.
Yeah.
Correct.
So yes, no, cloudy, all these things. So it's like a discrete kind of machine learning only. Yes. Now, what are the target features? What are the target features? Tell me. Target features are either it will rain or not. That's the target features. What is the input data? Tell me what might be the input. I have explained this thing in the last class. I just touched it. What are the input data might be? The input data might be the temperature or humidity. Yes. A wind speed, the pressure of the air, whether the place is the latitude and latitude belongs to a particular hill station or not. So all these things will be taken as a input data. Now, what kind of problem you are facing? It is binary classification or clustering. It is, you should supposed to know. It's a classification problem. Because first we'll read with the already existing data that whenever the temperature was that much, the cloudy was the nature, the cloudy was the sky, and the pressure was that much, and it was, that much humidity it has, that day it rained. So you are getting the data of Bangalore from the weather department. And you're analyzing that when the day when it was raining, what was the circumstances? What was the condition of the weather? So the data is already labeled. You know that for this condition it rained, and for this condition it was not raining that day. So the data is labeled in front of you. So it is known as the classification model. Yes. So I think I'm going through a bit advanced level now. So it's a classification. Just to keep this term, okay, classification. I'll go through with that. It is supervised learning method. It is supervised because the data is labeled. You know that for which condition the output prediction is yes. So whether the temperature was 20 degrees centigrade to 22 degrees centigrade, and the weather was partially cloudy, the temp and the humidity was more than 80%, that day it rained. So the predictor variables are this temperature of this level of this much 22 degrees centigrade. The cloudy was partially, and the humidity was more than 80%. Pressure was that much. Those are the predictor variable. What is the responsible? It rained. So you're giving this data to your algorithm. So your algorithm is learning that for this condition it rained, and for this condition it has not rained. So in this way you are collecting the entire data. So when it was raining and when it wasn't. So you are getting the entire data in this way. Are you clear? Yes. So that's the first step. We should supposed to know about your objective first clearly. Next is that to collect the data gathering. So data such as weather conditions, that humidity level, temperature, pressure, etc., are either collected manually or scrapped from the web. So it's a very difficult process actually. You don't take it simply, because data collection, no one will give you their data actually. No one will give you, no server and no company will give their data to you. No one will trust you, and they'll give the data that you are doing for a good job. You can do it for exploiting their company also, exploiting their organization also. Many people can do that. So it's very difficult to gather the data in a proper way. But however, you can do it. Yes, because we have Kaggle. It's a very time-consuming job. So we have data repositories like Kaggle we have, and many other repositories are there for machine learning. Kaggle, why I'm taking the name Kaggle? Because it's the most famous one. You can get sample data sets from the machine learning, data sets. For machine learning, the sample data sets are available in kaggle.com. So you can get the download from the data from now, and you can model and you can learn for the time being. So when you'll get a job to a particular company or you'll go for a particular research, they will provide that data later for you, and you can work practically over there. Kaggle is also having the data set which are practical actually. Okay, it is not like their synthetic data set they have scrapped from their own. They have also collected from different sources and give it for you. So the second step is data gathering, and it's very important level step also. The third one, the preparing the data. So preparing the data is required, otherwise your algorithm won't work with the raw data set. And if it works, it cannot give the proper efficiency. So data cleaning is required for preparing data. Data cleaning is very much important thing, because the data which you'll get, the raw data is not clean. It has lots of ambiguity and lots of the nonsense things, and a lot of the things which you don't require actually for your machine learning job. So what you'll do for that? You'll go through with those data? No. Yes. So you'll clean the data to to get rid of inconsistencies in data, such as we will be having missing value for many columns, for many features, many attributes. The missing values you can just remove, or redundant variables will be there. Many variables which you don't like actually to use. For example, weather data you collected, there might be the date. Sorry, not the date. Date is useful. There might be many data like who has collected the data. Okay, so the user's name, one column may be there. So you're least bothered about the user who has collected the data. Yes, at what timestamp the data has been collected. You are least bothered. You just want to get the data of the weather conditions. So those variables you will just remove that. You'll remove the dimensions. Then your job will be faster, right? Simply why to take burdens? Yes, we generally don't keep the burdens of emotions in our practical life also, right? We take off the emotions of many other things. So we take off many other habits so that we can shine in our profession, in our career. So many things we just want to go through, like supposed to have chat with the friends and to roam here and there, to have a bike ride or cycle ride or go through with the friends and all other things. We remove those things because those things are not good for our life, our future. Yes, we optimize. So similarly, many part of the data, we just get rid of it. We don't go through with that because it's not of importance. Simply why to carry the burden. Yes, so that's one of the reason of the preparing the data. Another thing is to transform the data into the desirable format. Suppose you just want to predict the data, and okay, Bangalore data you are collecting. So different people has collected the data from different places. Some have recorded the temperature in centigrade, degree Celsius, and some people have done in the degree Fahrenheit. So what we'll do with that? You have to transform the data. You have to make it in a single format. Either in Fahrenheit you do, or either in centigrade you do. And if the company wants it into the Fahrenheit, then convert to the Fahrenheit. If the particular authority wants into the Celsius, then convert to the Celsius. So this is known as transforming the data. Yes, guys. So these things we have to go through. That is known as the pre-processing the data, preparing the data. Next thing, step 4 is the exploratory data analysis. That is the exploring the data. So know your data. So data exploration involves understanding the patterns and trends in the data. At this stage, all the useful insights are drawn and correlations between the variables are understood. It's a very important thing. The correlation between the variables are required to be understood properly. Yes, like the what levels of temperature, humidity, and pressures are interrelated. That you should supposed to know. You should supposed to know that. Otherwise, the data learning, the model you cannot build. Like if the temperature is getting high, the humidity is getting low. If the pressure is getting low, then the humidity is getting up. So is this kind of relationships are there in your data that you should supposed to read and you should supposed to understand. That will be the step 4. That is the exploratory data analysis. Next thing is to build the machine learning algorithm. So you need the machine learning algorithm. So here, what algorithm you are using? Can you tell me? We are using supervised machine learning, correct? So any one of the supervised machine learning algorithm you have to use. Yes. How to create the model now? After as I told that the soul is the machine learning algorithm for creating the machine learning model, but this is not sufficient. We have to train it by using the training data set. Yes, the model is the machine learning algorithm that predicts the output by using the data fed to it. So building a machine learning model at this stage, a predictive model is built by using the machine learning algorithm. So here we can use the decision trees because it's a supervised learning method. So you should supposed to go through with that later. I can't explain you now the linear regression decision tree. It's a big concept. It will take 2 hours actually to explain each of the concepts. So just for the overview, a decision tree can be used for this supervised learning mechanism. It's an algorithm. Okay, decision learning is an algorithm for machine learning. The process of machine learning. Yes, this process of the machine learning. Oh, hold a minute. Hold a minute. I'm sorry, actually, but it's an important call. Hello. So guys, sorry for the disturbance. Actually, it's an important call. I can't take it off. So step 6 is the model evaluation and optimization.
Sir,
Mod
step 5 we have skipped. Step 5.
Step 5 I skipped. No, machine learning model I told, right? Yeah, I explained that, sir. Hello. So
Okay, sir. Okay, sir.
okay, sir. So step 6 is that model evaluation and optimization. So just you create a model is not sufficient. You have to evaluate, right? When you will evaluate a model, you understand the shortcomings and how to make it enhanced, how to make a betterment of the model is. That is known as the optimization of the model. So machine learning model is evaluated by using the testing data set. Now it comes the test data. Last time I was telling about the training data. Now it comes the test data. So just keep one thing in mind. Test data is smaller than the training data. Okay. Test data is smaller than the, suppose you are taking the training data as 80% of the input data. Then remaining 20% you'll use as a testing data. Or you're using 70% data as a training data. Then the remaining 30% will be you'll be using for the testing data. Okay, testing the model evaluation for purpose. The accuracy of the model is calculated over here. And further improvement in the model are done by using the techniques, okay, like the parameter tuning. So you'll tune different parameters and different options of the algorithms, and you see that how it's working differently, how the performance is getting increased. So in this way, you are learning from the environment, okay? You're learning from the system actually. That is the step 6, model evaluation. And the last one is the prediction. The final outcome is predicted after performing parallel tuning. There's the parameter tuning and improving the accuracy of the model. So you'll get the final predictions over here and the final things you'll get from there. So what are the types of the machine learnings are there? I'll try to touch it. Actually, I don't want to skip these things. So I kept all these things, okay? Because you should supposed to know, otherwise you don't know about the machine learning basically. If you don't know this next 3-4 slides is very important. So I'll try to go through with the real world example as much as possible, but the time is very limited, guys. So if you have any doubt, you can just poke me. I'll explain and clear your doubts, okay? But I'll try to be very much, very much precise and appropriate on these concepts, and not I'll go to very much details also. So there are 3 types of the machine learning. There are 3 types we can go through with the machine learning. One is the, just recall very properly, supervised learning. Number 2, unsupervised learning, and number 3, reinforcement learning. Number 1, I repeat, supervised learning. Number 2, unsupervised learning, and number 3 is reinforcement learning. So all these learnings are having their own applicability. In a certain condition, you have to use supervised learning. In another condition, you have to use unsupervised learning. And in another particular situation, you have to use reinforcement learning. So it's not like that you can choose, okay, today for this particular job, I'll use supervised learning, and for that job, we'll be using unsupervised learning. It's not like that. It's not your choice. It's the data, that the way data is fed to you, you have to decide that which particular learning you will be decided on. So first, let me explain the first one, supervised learning. So in case of supervised learning, the first criteria is that the data which you get is labeled. Let me repeat. The first thing about the supervised learning is that the data which you got is what? It's labeled. If the data is not labeled, then you cannot do with the supervised learning. You have to go through with the unsupervised learning. So what do you mean by the labeled data actually? The labeled data is that where the outcome, that is the response variable, is available. Along with the predictor variables, the response variable result is also available. So you can see that for these predictions, predictor variables, these are the responses we got. So as I gave you the example just before, if a person is daily purchasing or weekly purchasing or bi-monthly purchasing or monthly or at least purchasing bread, butter, okay, bread, jam, I told, I think, yeah, bread, jam, and what I told, milk and eggs. These 4 items he's purchasing regularly in Big Bazaar. So you should understand that he is purchasing breakfast. So that is an example of supervised or unsupervised learning. Can you tell me? Just try to tell me, is it an example of supervised or unsupervised? Just have a try.
Supervised only.
No, it cannot be told as a supervised because we don't know it is not written over there that it's breakfast. You are deriving it's breakfast.
No, jam is labeled, no, sir. The jam, bread, butter, whatever you
No,
told it is.
that are the predictor variables, sir. We are predicting based on that, but you don't know the outcome. We don't know the outcome, sir. Now I'll give another example. You are seeing that when the temperature of Bangalore is 20 to 23 degrees centigrade, the humidity is more than 80%. And what's the other one? And the weather is partially cloudy. It has rain. It has rained on that day. So when the temperature is from the range of the 20 to 23, humidity is more than 80, and the sky was partially cloudy. It has rained on that day. So it's a
Supervised.
yes, it's a supervised learning method. Why? Because we have the labeled data. That is the response variable is labeled. Predicted variables are there. We know the outcome of the predicted variables. That for these three predictor variables, the first predictor variable is what? Temperature. That also we know that this range. Next predictor variable is what? Sky, partially cloudy. That also predictor variable. The third one is also predictor variable. What is the other predictor variable? Humidity. That is more than 80%. So these three are the predictor variable, and their values we have. So for those predictor variables and their values, we have the labeled outcome, labeled response variable, that it rained on that day. So if you have such kind of data set with all the different weathers and their response variable, it is rained or not rained, rained or not rained, rained or not. For this range it rained, for this range it has not rained, for this range, suppose it was not cloudy, it was not at all cloudy, and the humidity was more than 90%, and temperature was below 15 degrees, that day definitely it rained. Although this, so that's another trend you are getting in the data, and labeled outcome also we have. So that's an example of unsupervised learning. Is it clear, guys?
Yes, sir.
Yeah. Anyone else any doubt in this example? I'll explain this. From this example, do you have any doubt?
No, sir.
No, sir.
Well, fine. So here we have given an example in front of you is there. What the example we have? We have the example of, sorry. We have the example of labeled data. See, it is clearly written that this is Tom. It's labeled. Here is also written it is Tom. Output is reveal. So you know this feature that it is gray and it is having this color whitish in the chest, and these are the features he has. Based on this particular predictor variables, the response variable is Tom. So it is the output as the response variable is labeled. So for Jamie, the color is yellow. The feature is what? This is one of the feature, right? Yellow. The face color is yellow. And the chest color is not same as Tom. It's something yellowish. Yes. And its ear color is something purple and near to that. Yes. For that, the outcome response variable is Jerry. So it's a label data. Is it clear to you guys? Yes, the output is known to you that for this feature, the output is this is Tom and this is Jerry. So the output is known output in the data. In the data, the output is known. So if you fed this kind of data, suppose this kind of data is given 1,000 lines of the data is given to you. So you can go through with the data cleaning, unwanted data you remove, and then you go through with the exploratory data analysis, then you implement the algorithm, and then you go through the model evaluation, and you can get the labeled output that for this feature it is Jerry and for this feature it is Tom. Got it? Now you learned that. Now similar data of the Tom and Jerry or any other data with this kind of images, if you just give to the machine learning model, it can easily understand that for this feature it is Tom, and for this feature it is Jerry. So it will be very quickly giving you the response because we already know the output. Known output was given into the label because the data input data was labeled data. Yes, but the same thing is not there for unsupervised learning. For unsupervised learning, the data is given to you, but the label is not available to you. And this is the real world scenario actually. Most of the real world data is actually unlabeled. Are you clear? So here you have the same data actually, but the label is not given to you. You don't have any idea that who is Tom, who is Jerry. Yes, Are you clear? So how you'll differentiate between them? You'll differentiate between their features. You'll see that what are the features of this it has based on the colors and its how its face, facial recognition. You can go through many other machine that we are not going to go to that detail. Many other things you can implement so that you can see that how it looks, how the body color it has, and how its other feature it has. So along with this particular guy, so this particular guy, which guy is matching? So this guy is matching with the color, and this guy is matching with the color and the features and the other features. These three are not at all matching. But along with this particular guy, this is matching and that is matching also. It is not matching with these three. So Tom and Jerry labeled is not there over here, but the features can be easily extracted. And based on that, we can put into the group. So you put into the group with the similar feature and put Jerry's into the similar feature and Tom's into another group based on the similarity among their features. Features means nothing but the dimensions or the variables in general. In practical terms, we say it's a variable only. Yes, and in a machine learning term or data mining term, we tell it as a feature when you go to the high level. Yes. So this is the way the clusters are formed. This is the one cluster and this is the next cluster. So in this way, it can understand the pattern and discover the output. That is the unsupervised machine learning problem. So unsupervised learning is the training of machines using the information that is unlabeled and allowing the algorithm to act on the information without guidance. So you don't have any guidance. Yes, for the Bangalore's weather prediction, we have a guidance that for this particular weather range at this particular range of temperature, humidity, and the sky condition of cloudy and all, it may be raining and all. So it has rained already based on those data. But here in this case, you don't have any data for that. You don't have the output data at all. The response variable you don't have. You have to solely rely on the predictor variables. And you have to see that the features among the data and you have to group them. That is known as the unsupervised learning. So the K-means algorithm can be used for this purpose. K-means is the unsupervised learning. So I give an example of the algorithm known as the K-means, right? So we can see that this is an example of K-means. Yes. Are you sure? So you can give, if you execute K-means on a sweet shop, suppose, it will separate rasagullas in one and then gulab jamun in one, and it will separate and many other sweets made of ghee and all, Mysore pak and all those things can be separated based on their own features. So you don't tell that this is the Mysore pak. It's not written, it's a Mysore pak. If this is the size and all, that is my Mysore pak. No. So nothing is written over there. So you have to understand by the color, the size, by the material, what the uniqueness it has. Based on that, you will group the rasagullas in one place, gulab jamun in another place, Mysore pak in another place, and so on. Yes, and laddus in a different place. Its texture and its colors is different. Motichur laddu will be into the different place. Yes, based on this thing. So automatically it will learn from the data. It will separate the different places. And if it is like that, okay, if it is spongy, white, put into the soup, then it is rasagulla. If such kind of data you get for each and every sweet, then it will be supervised learning method. And if there is no data, just the things are there, randomly you collect the data, you learn from the data, then it is unsupervised learning mechanism. So this is the difference between supervised and unsupervised. So any data between this, any doubt between these two guys, you can ask me now. Anyone can ask me here. You can make your doubt clear. My main focus is to make you clear and enable you with the machine learning. Hello? Any doubt on this?
Sir, one doubt, sir.
Tell me.
Sir, in unsupervised learning, they give some examples like the speech style. We don't have the shape as its parameter. But sir,
Can
so
you repeat,
in
please?
An example, one more example I asked you for unsupervised learning.
Okay.
To understand it clearly.
Okay.
That's it.
Another example should I supposed to give for unsupervised learning?
Yes, sir. Yes, sir.
Okay. suppose you are gathering documents, and so I'm giving a real world example. Okay, that will be all better. More than that will be better for you. Well, Google News, there is a Google News.
Yes, sir.
Yeah, news.google.com. So Google News doesn't have any authority because of collecting data. They're not an agency. Google has no agency to collect the data. What they do is that they have subscribed and paid money to Hindustan Times, to Times of India, to the Telegraph, to all the newspapers of India and abroad. Okay, so they will provide the data to him. Are you clear?
Yes, sir. Yes.
Yes. It executes its own unsupervised learning algorithm to separate the data into different places from the news data and categorize that these are the data will be the top stories because people are reading. And these are the data is of the political. These are the data of, political. This is the sports, this is the religion, this is the lifestyle, and this is the traveling, and this is the sports. And all the categories, they make them all by using the clustering actually, by using the unsupervised learning actually. So they get the data based on the document. They check the similarity between the document, what the document is being discussed actually. Based on that, they gather it together. And in this way, they gather it and provide you the data. So it's known as the document clustering, text clustering. Yes, it's an unsupervised learning method.
Okay. So after collecting all the data, we actually label the data before the training process, right, sir?
Yeah.
Okay. So we're supposed to do the labeling.
Let me give you another example.
Okay, sir.
So you have a particular database, okay, of suppose amazon.co.in. They have a database. They just want to segregate the users. It's a clustering problem actually. Segregation of users. You just want to see that what are the users are purchasing more items from your company, from your what's that e-commerce website Amazon. You just want to see that. So you are grouping the customers because those who are purchasing more, they are your good customers. You want to provide them more flexibility in terms of the what was that reduction in the 10% discount and all these things. Yes. And those who are not at all purchasing, like they once upon a time in 6 months they purchase one, you just want to make them in a different category. For them, you want to treat differently. That's the objective. So to make that objective, what you are doing, you are grouping the customers. How will do that? You will go to the database. You'll see that for each particular amount of time, how many customers has purchased more things and what are the items they have purchased. So you will be using a clustering algorithm over there. Got it?
Yes. Now
Yes.
I got it.
Yeah. So that becomes what the clustering is.
Thank you, sir.
Are you clear?
Yes.
Yes. So Harika has given something I think into the group. He has pushed direct message. She says, teacher teaching is called supervised learning. Self-learning is called unsupervised learning. Yeah, in real world, you can say that. Well, so we'll go to the next topic. So any other doubts remaining over here? Supervised and unsupervised learning? Hello? Anyone, any other doubt you have?
No, sir.
No, sir.
No doubts.
Well, so now we'll be learning the third way, the third type of the machine learning, that is reinforcement learning. So what is the reinforcement learning? It's the part of the machine learning where we have an agent. This is the very important term, agent. That agent will put into an environment. That's another important term. There is an agent, there is an environment. And the agent will learn to behave in the environment by performing certain actions and observing the reward which it gets from those actions. So you suppose you are an agent. You have been put to a particular environment. Now you'll do something automatically and learn from there. When you learn, it is a reward. When you can't learn, it's an error. So slowly you are getting the rewards and learning something fully automatically. Yes, so that is known as what? Reinforcement learning. It's totally different from the supervised and unsupervised learning technique. The example is, suppose when you might be a kid, your parents might have sent you to learn swimming, correct? In the swimming pool, and there is an instructor. So what some instructor is to do with me is that there's to throw us into the swimming pool. Yes, So I'm an agent. Swimming pool is the environment. And how we used to learn, actually, we used to behave, how we just wanted to float so that we don't drink the water over there. There was an instructor, he used to take us off if he used to drink water and about to, because there was no life-threatening condition over there, we had an instructor. But he used to throw us so that we can learn automatically from the environment. And slowly, actually, that way we learned swimming. So there was no supervised or unsupervised method. We are not calculating that what are the system, for how much hand to be put over there and how much to be float, and there is a then we learn swimming. Or if you float in this way, following this predictor variables parameters, then we can swim at the end. Then it will be supervised. And if you just learn that, okay, when you jump over there, the water is having this much floating, and that much it has the capacity to float, and if you go through that, then we can swim, and all these things is not possible at all. It's not unsupervised also. It is the reinforcement learning. You enforce yourself to difficulty, to an environment. You learn slowly, one by one, get the reward. So first we used to get drink, then we used to know that, okay, there is a way to float. We have to just put our hands continuously. So it's to put our hands and legs, very fast, and somehow for maybe some 10 seconds we used to float. Then we used to stand on that. Then again we tried the same thing. Then we used to put our hands onto the side of the swimming pool, and used to put our legs, our body straight, and used to put our legs fast. Yes, because we didn't know that. Slowly used to learn in this way. So that's what we're learning. The agent is the learner, and the environment is the swimming pool. And in this way, we are getting learning in the environment by performing different actions. And sometimes the actions are giving us rewards. We are keeping the rewards in mind. We are also keeping the errors in mind also. That if you do like this, then we'll get down. And if you are doing this way, we are slowly floating. And this way we learn the floating. So that's what the reinforcement learning is. So here the Tom, Jerry, the same notation is given over here. Is it a Tom or Jerry? Yes, it is putting over there. It's become an agent. So it's doing some actions. Yes, in this particular environment. If it is proper, then you are giving the reward. So reward will be added. Yes, the state is also provided. In this way, if it is matching the way Tom works or the way Jerry works, then it will be Tom or Jerry. It will gain the capacity of being a Tom or being a capacity of a Jerry. Got it? Suppose I'll give another real world example. Suppose you know a child, right? You might have a child at your home. You might have some cousin or someone else, maybe your brothers or your sister's daughter or son. So you know that when they start walking, yes. So it's a reinforcement, is an example of reinforcement learning. They start over there and they're going to walk up to some level. So the kid is it's an agent. The environment is the floor, and there is a target actually. Suppose the target is he or she wants to go and touch the chair. Okay, just some 5 feet away or 10 feet away. There is a chair. So that's the reward, the final reward. That is the final reward. So he or she will start going and several times will get down. So that's an error. He or she is learning from there. Then again, he's getting up and start trying walking. So that's slowly, small rewards is getting and learning from the error also. At the end, he or she is going and touching the particular, what's that? Chair. So that becomes what? That becomes the reinforcement learning. Or you might have known about you might have played Counter-Strike. You might have played Counter-Strike or similar games, similar, maybe IGI at least you have played, might be. Yes, or any other games where you kill others, kill your enemies by shooting or using sword like Prince of Persia and all. So what you do over there, you first, when you start the game, the first stage, you just go here and there randomly. So you're the agent. Yes, you're learning here and there. You're just running here and there. You don't have any idea where to go and all. Whatever you're searching for, directly you're killing them. You're shooting them. Yes. So in this way, you're learning from the environment. You're going one by one. How you'll get the reward in terms of the life, in terms of the new weapon. Yes. Or you get the points. In this way, you keep on getting the rewards, and you go to one by one stages and all, stages higher and all. That's how the games work. So that's an example of reinforcement learning again.
Sir, when I used to take in classes on this, so I used to use PUBG example because most of the youth have played that. So whatever the character that they play in PUBG, right? So that
Yeah,
is equivalent of an agent, and whatever the maps that they play, that is equivalent of an
environment. Yeah, yeah, yeah.
Yes. And
Yeah.
the reward is the final chicken dinner that they get, and the upgrade and the points. So
Yeah, yeah.
if they die in the middle, and if they know that this
That's
is
error. That's error.
yeah, that's the error,
That's
and
the error.
that will be penalized. Like they will avoid that place or that situation in which they died, and they try to improvise and maximize the reward. That is
Yeah, yeah, yeah,
the chicken
yeah,
dinner.
yeah. Yes, yes, yes. Games are very good example of reinforcement learning actually. Computer games.
Yes, sir. But the other major drawback is with respect to environment. So if the agent gets well trained in an environment, it will perform really well. But if something changes in an environment itself, then the learning process has to, go through again and again, and we have to readjust the things. How it is
That's the part and parcel of AI, na? That's the part and parcel of AI. See,
Yes,
all
sir.
modern games are having AI, right? So how they'll implement AI? Because you are learning reinforcement learning, right? Suppose you're playing the game. Suppose IGI you are playing. Okay, so you get inside a room. Okay, enemy room. You are going to win the particular. You have to kill all the enemies and get to the truck. Okay, the objective is to get to the truck. Yes, the truck has suppose the nuclear formula. You have to get to the truck and bring it to your country. I think it's a Russian game. I can't recall now. It's been too long. I played the games and all. So it's like you're going over there. Okay, you're going over there, and then you are seeing that when you get inside the room, from right hand side one enemy is coming and shooting to you. You have to shoot and kill him. Correct. But when you're suppose he killed you. Okay, but when you are going to the next time, the enemy will not come from the same direction. There might be no people over there. So the computer is learning your condition also. Understood, na? The way you are playing
Correct,
last time,
correct.
the same way they will not feed you the enemies. So it's a part of the artificial intelligence. When you play something very hard, that you go to the different levels, they will play. The computer will play with you in a different way. Correct. Another example is suppose the cars. Now these automated cars. How these automated cars are working? The automated cars are working based on it's a very complex thing actually. Deep learning is there. We have the machine learning over there, and there is reinforcement learning is also there in part of the machine learning over there. So you learn from the computer vision. From the computer vision, you learn about the roads and the fabrics and each and everything, like a real man and our retina can synthesize. The same way you are learning. Yes, and when you are following something, suppose some mistake you are doing in the learning phase, you are learning from there. From the error you are learning. And when you're going properly, from the reward, you are getting confidence that yes, this car should be designed in this way. This car should be this, or Tesla cars, like for example, they learned in this way. They have implemented reinforcement learning or machine learning. Yes, to learn, to get into the reinforcement learning as an input, they have computer vision. Yes, and to make it fast, to go through in details, they have used neural network. So it's a very complex thing. Okay, but the thing is that the reinforcement learning is being used. That's what the thing I just want to tell you.
Yes, sir. It makes more sense so that it reduces the training time as well as the model conditions. If the environment is prefixed, say for example, in a chess, you have just 64, blocks of white and black combined. So
Yes,
that is a fixed environment. So there is no other variable that comes into the picture like a computer game, because in a computer-based gaming applications, so what we see is like there are too many factors, like the bots can come in from another way. The way in which it is approached, it can be different. But in a fixed environment, it's much more favorable on this.
Yes, true. It's far complicated than a chess game. Chess game is nothing. You can't compare chess game with a car or a modern game.
Correct.
Okay. So this is the difference now between the different types of the machine learning over here. So should I go through with that, or you can just go through? I'll give the PPT. You can go through with that, I think. Okay. So I'll not go through with all these things. I'll not read it out. So there are three different examples. We have the regression, classification, and clustering. Yes, you can go through with that. This clustering part I'll explain in the afternoon class. Okay, in afternoon session, I have to teach you this afternoon classes. I have to teach you in detail with this particular things. Clustering. I'll show you with the K-means clustering in detail. I'll explain about the K-means clustering. I'll go through with that. So now we'll go through with the difference between the AI, ML, and DS. What's the difference between artificial intelligence, machine learning, and DL? So artificial intelligence is a broader chapter. It's like a book itself, and the part of the book is machine learning. Yes, there is a chapter in the book, big chapter known as the machine learning. Artificial intelligence is the technique which enables machines to mimic human behavior. Like machine will be acting like a human being. It will emulate, it will mimic, it will copy human behavior, but it will learn using the machine learning. The machine will learn by using the machine learning. So it's a subset of AI technique which use statistical methods to enable machines to improve with experience. And deep learning is a part of machine learning. It's a subset of AI technique which makes the computation of multi-layer neural network feasible. So by using machine learning, we cannot do certain things. It's very difficult to do by using machine learning, especially we known as when the dimensions becomes very high. Suppose for image recognition, for image identification, or from the video number plate identification, that problem I told. So that's an example where the machine learning will be very inefficient. It is known as the curse of dimensionality. Lots of the different dimensions will make a machine learning algorithm goes very poor in performance. On that case, we require deep learning. So these three things are interrelated but not same. Yes, suppose you take an example, the problem, a problem with the machine learning I'm telling you. You suppose you put it here, you watch at my cursor, you have a particular thing over here, this coin over here. So this coin you put over here, so a person can go directly in one dimensional way and collect it. If it's a two-dimensional space, then you put a coin, then he has to go through each dimension and get the coin. And if you put it into a 3 dimension, then to search the coin, it will be very difficult because we have the 3 dimensions. Either it is going depth is also added with the height and width. Okay, similar thing it happens with the image recognition. For recognizing an image, it's a n into m matrix. It's a high dimension, and all the each and every pixel you have to go through for understanding a particular image, a part of the image over there. So one of the big challenges with the traditional machine learning model is it's a process called feature extraction. So feature extraction will be not an easy thing to do. Yes. So like a real world image, to get the to get what features from the real world image. Suppose there is a there might be, suppose how much pixel, suppose it's 28 by 20. So 28 into 28 into suppose 16,000 colors are there. So 16,000 pixels, more than that pixels will be there. So that much has to be multiplied. So that big will be the space. So from that space you have to retrieve the feature. So that will be very difficult. It's a very complex problem. Yes, so similar it happens for the handwriting signature, recognitions and all these things. So it's not possible by using machine learning. We go for the deep learning for that. So why it is deep learning? Why deep learning required? Deep learning models are capable to focus on the right features by themselves. It's a very important thing actually. That's the point which comes in favor of the deep learning. They can feature by themselves. They can go through with that. If feature extraction happens automatically, very little guidance by the programmer is required to mimic the human behavior. Yes, these models are partially solves the dimensionality problem. The high dimensionalities can be easily dealt with that because the users, because the model automatically learns. So as you can see over here, this is the image. Yes, this is the image. This image has to be identified from this set of image. We just want to get individual image photos. Yes, individual person's photos. I mean the pictures. How you can understand? So based on the number of pixels, we'll set the first layer of neurons. What is this? I'll explain later in detail. Now from there, each neurons will be connected to the next layers. In this way, we'll just get that wherever a picture, suppose my face is there. No, so up to that, my face is dark. This having a different color. And this space, as you can see, this space is having blank. So this is my face. We can understand. So similarly, from this particular image, now with so many images are there in each rows and each columns, we can separate by using their intermediate spaces. So from there, we can understand that these many pictures are there. So so in this way, it will get the pattern of local contrasts. Yes, the first input layer. Now the output is fed to the next input layer. Next input layer automatically see only the face features. It will separate the face features, the first hidden layer, and give the output to the next hidden layer. So next hidden layer will get the features from the face only. Only the face will be retrieved back, and that will be outputted. So in this way, automatically, the deep learning will build the learning algorithm to mimic the brain. The brain works the same way, actually. I think this thing has been covered by the other, uh, resource persons. So I'm just going through a bit faster. I hope that you can understand. Yes, are you clear? So how it works actually, how it works by building a model to and determine which feature or variable is important in reducing the, getting the output over there. Yes, and the outer layer. And when many features, like in a high dimensional space, there are many features, right? So when there is many features are available, yes, many features are available, how to sit down and analyze the interrelation among the variables. That's a part of the machine learning, right? In machine learning, we go through the exploratory data analysis, right? It's not possible when the features are very high. Suppose in real world image data set, there might be 20,000 or 1 lakh features. Suppose a data set is there. How will do with that? How will do to analyze the interrelation between those many variables by using machine learning algorithms? It's not possible. So deep learning features on its own and step by step reaches the goal, actually. Yes, so that's what's happened in the face recognition also. In face recognition, if you give it to machine learning, it will select the features from the face, like the nose, its eye, its ear, it's the color, this is that, like that. It will go through with one by one. You have to feed each and everything in the machine learning algorithm and its model. But if you give the face recognition to deep learning will use the neural network, and it will automatically determine the features step by step. And if some features are wrongly determined, then you can go to the back propagation. That is, it can
Any problem, madam? Hello? Hello? Hello?
Madam, any